So this is video number 3 of chapter 3, and it actually goes with an extension. Sorry, I should have put that. It goes with 3.2 extension in the book, and it's on factoring expressions. So we're going to be able to factor out the greatest common factor of linear expressions. So for the vocab, we need to know what it means to factor. The first definition here is the technical definition in your book. It says to write an expression as a product of factors. So hopefully you remember that product means we're multiplying, and factors are things that get multiplied together to give you a product. So we're going to be looking at what gets multiplied together to make that expression. Our normal, everyday definition of factoring is going to be to pull out or to divide out the greatest common factor. So we have to remember what a greatest common factor is. A GCF, or greatest common factor, is the biggest thing, greatest, shared thing that goes into both of them. So that is a factor of both of the numbers. The biggest thing that goes into both of them. So I'll do a few as examples and then you can try a couple. When I look at 2 and 10, the biggest thing that's going to go into 2 and 10 is just going to be 2. 3 and 24, the biggest thing that's going to go into 3 and 24 is just going to be 3. That's the greatest common factor. How about this one, 14 and 49? Well, the biggest thing that goes into both of those, if I think of all the numbers that I can use to make 14 and 49, it's going to be 7. 7 goes into 14 twice. 7 goes into 49 7 times. But it's the biggest thing that goes into both of them. So right now, try number 3 and 5 and 6 as practice. So pause, and then we'll come back and check. Okay, here's what I got as the greatest common factor. 9 for this one, that goes into 9 and 27. 6 goes into 24 and 42, and then 10 goes into 50 and 90. So when we factor, we're going to divide out. We said divide out the greatest common factor. So let's do a few together. 24 and 18. What's the biggest number that goes into both of those? You're thinking, okay, 6. So when I divide out the 6, it gets written out front, and then I say, okay, what's left from this term if I divide out the 6? Well, 24 divided by 6 would be 4, and I still have the x. And then I look at this term, and remember that negative is glued to that 18. So negative 18 divided by 6 would be negative 3. Now, factoring is kind of like the opposite or the reverse of using distributive property. If I want to check my answer, I would multiply this back together. 6 times 4x is 24x, and 6 times negative 3 is negative 18. So I can always check my work and make sure it's correct. Okay, how about the next one? Well, what's the biggest thing that goes into 6 and 27? That would be 3, right? So if I divide out the 3, well, 6x divided by 3 would leave me with 2x. 27 divided by the 3 would leave you with positive 9. And then you can always go back and check. 3 times 2x is 6x. 3 times 9, positive 27. So we're good. How about the next one? 12x or 12z and 40. What goes into both of those? 4. So if I pull out the 4, give myself a little bit more room. Pull out the 4. So 12z divided by 4 would be 3z. And 40 divided by the 4 would be positive 10. And I'll check it just to make sure. 4 times 3z, yep, that's 12z. 4 times 10, yep, that's 40. So I know it's right. Another kind of example is if you have a negative out front. So we're looking at these over here. A negative 3x plus 12. Well, when you factor, you don't want to have negatives right here in your parentheses. So we don't want that first term inside the parentheses to be negative. So that means I have to pull the negative out front. So when I look at negative 3x and 12, negative 3 would be the greatest common factor I want to pull out. So now I just got to be really careful because remember I'm dividing by this negative 3 now. So negative 3x divided by negative 3 would leave you with just a positive x. And then 12 divided by negative 3 is actually negative 4. So we can always go back and check that. Negative 3 times x, yep, negative 3x. And negative 3 times negative 4, yep, positive 12. Okay. Again, this next one, I see a negative here, so I know I want to pull out a negative number out front. And the biggest thing that goes into 8 and 20 would be 4. So negative 4 is my greatest common factor. Then negative 8x divided by negative 4 is positive 2x. That's what we wanted. We wanted that to be a positive inside the parentheses. And then negative 20, remember that's all negative 20 divided by negative 4 is positive 5. Always check it. So do the distribution back and make sure. Negative 4 times 2 is negative 8x, and negative 4 times 5 is negative 20. Good. All right. So think about these next two. What should we pull out? Well, between 6 and 3, my greatest common factor is going to be 3. But I see here, because my first term is negative, I want to pull out a negative 3. And what would be left? Negative 6x divided by negative 3 is 2x. Good. This ended up being positive. And then 3 divided by negative 3 is a negative 1. And then go back and check it. So negative 3 times 2x, yep, negative 6x. And negative 3 times negative 1, yep, positive 3. All right, and this last one, I have a decimal out front, but that's okay. Let's see if that decimal, 2.5, does that go into 7.5? So let me think. I got 2.5. If I'm counting by 2.5s, 2.5 plus another 2.5 plus another 2.5. Yeah, it goes into 7.5. So it looks like I can pull out the negative 2.5. Then see what's left. Well, negative 2.5 divided by negative 2.5x right here divided by negative 2.5. It's just the x. And then negative 7.5 divided by negative 2.5 is going to be positive 3. Let's check it. Negative 2.5 times x, yep. And negative 2.5 times 3 is negative 7.5. Good. Okay, the next examples are factoring with fractions. So you might see questions like these where it says factor out a fraction, factor out 1/2 out of this expression. Well, 1/2 does go into both of those, so I'm going to write the 1/2 as my greatest common factor out front. When I do 1.5x divided by 1/2, I'm left with just the x. And then 3/2 divided by 1/2. Well, we're saying, okay, how many halves does it take to make 3/2? Well, it would take 3 of them. And that's a positive. So that's what I would get here. Let's check it. 1.5 times x, yep, 1.5x. And 1.5 times 3, 3/2. Looks good. Okay, for this one, it says factor out a 1/5. So when I factor a 1/5 out of 1/5 x, I just have the x left. And when I factor out a 1/5 from negative 4/5, well, I would get the negative 4. Because when I check that again, 1/5 times x is 1/5 x. And 1/5 times negative 4 is negative 4/5. Cool. All right, so try these two. Right here, there's 2 more examples. Think about what you could pull out and rewrite it when you factor out the fraction. So pause and try them. Okay, in this one I pulled out the 2/5, right? 2/5 times x is 2/5 x. And then 2/5 times a negative 2, right? If I do negative 2 times 2/5, I get negative 4/5. That's what I wanted. And in this one, pull out the 1/4. And then let's check it. 1/4 times x gives you 1/4 x. And 1/4 times 2, well, 2 times 1/4 gives you 2/4, or that simplifies to the 1/2. So you might have to think a little bit about common denominators and how many of those fractions it takes. But we'll do more practice with this in class 2. Okay, here's some practice for you. I wanted to talk about just these top ones for a second. You'll notice that they have different variables, and we haven't seen ones like that before, but it doesn't change the problem. You still just look for the common factor with the numbers. So it looks like 10 would go into both of those. If I pull out the 10, I would have w for the first term and 5z now for the second term. In the next one, I can pull out, a 2 as my common factor. So 10v divided by 2 would leave me with 5v, and 12u divided by 2 would leave me with 6u. That's cool. And the next one, 3? So if I pull out the 3 as my greatest common factor, 9a divided by 3 is 3a. And 15b divided by 3 is 5b. So even if the variables don't match, they just kind of hang along. They just tag along. You do them the same way. So try the rest of these. There are 3 normal ones here, and then 3 other ones to try as practice. So do those and then pause and come back and check. Okay, here's the answers. Just make sure every time you do a factoring problem that you actually go back and do the distribution to check your answer. So every time you should be saying, okay, let me check. 7 times 3w, yep, 21w. 7 times 4, yep, that makes 28. Factoring is actually easy if you think about it because you can always check your answer and make sure it's right. So that's our video on the extension, 3.2 extension on factoring.